Video is about solving systems of linear equations with substitution. So to begin with, let's review system of linear equations. So a system of linear equations is a set of two or more linear equations. An example might be this system right here, y equals 3x plus 2 and y equals 4x minus 1. The solution to a system of equations is the ordered pair that makes both equations true. So in the last video, we talked about how we could graph both equations on the same set of axes. So one might be here and one might be here. And then our solution is where those two lines intersect, or the ordered pair xy that satisfies both equations at the same time. If we were to think about an ordered pair here, that would only satisfy this first equation, right? Or an ordered pair here would only satisfy this equation. So the solution is the ordered pair or the point of intersection that makes both equations true. So we have multiple ways of solving systems of equations in addition to those tables and graphs that we talked about in the last video. So this one is about substitution. So let's think again about our solution to this system of equations. So it's this ordered pair where these 2 points intersect. So that means that the x and the y value are going to be the same for both equations. So if we think about the x and y value being the same for both equations, that means that this y value right here and this y value are equivalent. Well, if this y value and this y value are equivalent, then this must also be equal to this. So if this y is worth 3x plus 2, this y down here must also be worth 3x plus 2. So I can substitute, I can substitute the value of one of the y's in for the y of the next equation. I can do the same thing with x, but in this case, y is easier. So I can plug in 3x plus 2 wherever I see a y in that second equation, and I would get 3x plus 2 equals 4x minus 1. When I solve for 3x plus 2 equals 4x minus 1, I can subtract 3x from both sides. I get 2 equals x minus 1. I can add 1 to both sides, and I get that my x value for this point of intersection for my solution is 3. But remember, our solution is an ordered pair. It's not just one value. So if I know that my x value is 3 for my solution for my ordered pair that makes both equations true, I can then take that 3 and plug it in for the x in one of the two equations and get my final answer. So if I plug in 3 for this first equation, I would get 3 times 3 plus 2. 3 times 3 is 9. 9 plus 2 is actually 11. I don't know why that says 8. So our y value is 11. Let's double check it in the second equation just to make sure. So y equals 4. I'm going to plug in 3 for x because that's what my solution says, plus or minus 1. Oops. So 4 times 3 minus 1. We know that 4 times 3 is 12. 12 minus 1 is 11. So that means that our final answer has the ordered pair, or is the ordered pair 3, 11. When I plug in 3 for x to both equations, my y value is 11. If we were to graph these two lines on a set of axes, 3, 11 would be this point of intersection, an ordered pair that makes both equations true. Okay, so pause the video and practice these two on your own, and then when you're ready to check them, you can press play again and see how you did. Okay, so in this first system of equations, this one is a little bit different because they aren't both in the form y equals mx plus b. So our first equation, we have 3x plus 2y equals 6. Our second one is y equals 2x minus 4. So we still know that our solution is going to be an ordered pair xy. So that means the x and the y are going to be worth the same in both equations. This y is worth the exact same as this y. So what I can do is I can see that this y is 2x minus 4. I can plug that in wherever I see a y in that first equation. Okay, so now we have 3x plus 2, and I'm just going to leave a space wherever there's a y, equals 6. And now I can go back and I know that this y is worth the same as this y, which is 2x minus 4. And we do this so that we have only one variable to solve for, and it makes the equation solvable. So now 3x plus, let's distribute our 2, 4x minus 8 equals 6. 3x plus 4x is 7x minus 8 equals 6. We can add 8 to both sides. 7x equals 14. Oops, divide by 7, and we get that x equals 2. But remember, our final answer has to be an ordered pair. It's not just one x value. So now what I can do is I can take my x value and plug it back into one of these equations and solve for y. So the easiest one to plug it in for is the second equation because y is already isolated. So we get y equals 2 times x, which in this case is 2, minus 4. 2 times 2 is 4. 4 minus 4 is 0. So our final answer must be the ordered pair 2, 0. All right, let's look at the second one. So 7y plus x equals 13. 3x plus 4y equals 46. So this one is even different from the previous one because none of the variables are already isolated. So when you come across something like this, the easiest thing to do is to figure out which equation has a variable that is easily isolated for. So it would be this first equation. X doesn't have a coefficient, so it's going to be really easy for us to manipulate this equation to get x by itself. So I'm going to use green over here. So 7y plus x equals 13. If I want to get the x by itself, I just have to subtract 7y from both sides, and we get that x equals 13 minus 7y. So now I have this equation and this equation that I can use. Now keep in mind, x equals 13 minus 7y is the exact same as 7y plus x equals 13. Those two equations are equivalent. All I did was move the 7y to the other side. Okay, so because these, the solution will be an ordered pair that makes both true, the x's will be worth the same and the y's will be worth the same in both equations. So I can take what x is worth, 13 minus 7y, and plug it in for the x in the next equation. So now I have 3 times whatever x is worth plus 4y equals 46. Let's plug in 13 minus 7y for our x. Solve, so we get 39 minus 21y plus 4y equals 46. 39 minus 17y equals 46. Minus 39 minus 39, negative 17y equals 7. Divide by negative 17. Y equals negative 7 over 17. But remember, that's not our final answer. We do have to solve for x because our final answer is going to be an ordered pair. So I can take this y value and plug it back into one of the equations. So I'm going to say x equals 13 minus 7 times negative 7 over 17. X equals 13 plus 49 over 17. Let's see, 13, let's make this common denominator. So that would be x equals 221 over 17 plus 49 over 17. And x would equal 270 over 17. So our final answer would be the ordered pair, 270 17ths, negative 7 17ths. There are more practice problems under this video on your Canvas page that you should be practicing.